Welcome to the first lesson in session 4 on the equation and graph of a hyperbola. A hyperbola is a smooth curve that looks like two mirrored parabolas. Each one is called a branch. A hyperbola has two branches. So as you can see in the picture, in this case one opens left and one opens right. We'll also study hyperbolas that open up and down, but in each case they are two mirrored parabolas. Each one is called a different branch. So the components of a hyperbola are as follows. There's a center, which has coordinates of hk. The hyperbola provided has a center at the origin. There are two vertices. And the vertices are the closest points on each branch to the center. So in this case, negative 4, 0, and 4, 0 are the closest points from each branch to the center. The distance from the center to the vertices is given by the value of A. And there's a transverse axis. The transverse axis passes through the vertices and the center. There are two asymptotes. And asymptotes are lines that continually approach a given curve but do not meet the curve. And the asymptotes, when we'll study when we graph hyperbolas, help us determine how wide or how narrow the branches of the hyperbola are going to open. And lastly, there's two foci. And the foci, similar to that of the ellipse, the foci of a hyperbola are going to be tucked just inside the curve of each branch. So in this case, the hyperbola given, the foci would be negative 5, 0, and 5, 0. So notice how you have the center, and then as you move away from the center, we have the vertice. Each branch has a vertex, and just tucked inside each branch, you have a focal point. And when we study standard form of a hyperbola, there are two different equations we need to remember. There's one with a horizontal transverse axis and one with a vertical transverse axis. They look very similar to that of an ellipse, given that they have a squared and b squared in the denominator, and they're both equal to 1. The way to differentiate the equation of an ellipse and the equation of a hyperbola is that there's a subtraction sign in between the two terms on the left side. So where the ellipse adds the two quadratic terms, the hyperbola subtracts the two quadratic terms. So for the horizontal transverse axis, you have x minus h quantity squared over a squared minus y minus k quantity squared over b squared equal to 1. So, and the vertical transverse axis leads off with y. So you have y minus k quantity squared over a squared minus x minus h quantity squared over b squared equal to 1. So the way to recognize the points of a hyperbola, as far as the denominator goes, a squared is always listed first, b squared is always listed second. In the horizontal transverse axis, x is listed first, and in the vertical transverse axis, y is listed first. So here we're going to graph the hyperbola. X squared over 25 minus y squared over 9 equals 0. So here are the steps to graphing a hyperbola. First thing we have to do is find the center. Remember, the center is given the values of hk, just exactly the way we find the center of the circle, and the same way we find the center of the ellipse, we find the center of the hyperbola. So h and k are given as the values of the center. For the hyperbola that we have, the center is at the origin 0, 0. After we identify the center, the next thing we need to do is plot the vertices and the covertices. Now we look at the parabola we have. X squared is the first term. X squared is the positive variable. So that tells us since x is first and it's positive, we're going to have a horizontal transverse axis. So the vertices are going to lie 5 units to the left and the right, because that's the square root of 25, and 3 units up and down from the center. So there's an example of my vertices. So I apply 5 left and right because that's under the x, which is my horizontal axis, and 3 square root of 9 up and down because that's my vertical axis. Once I've plotted my vertices and my covertices, I'm now going to draw a rectangle that's going to pass through all 4 of those vertices. So there's there's the rectangle that's going to provide me with the slopes of the asymptotes. So now that I've drawn my rectangle that passes through my vertices and my covertices, I'm going to draw the diagonals of that rectangle. And the diagonals are what provide me with the vertices. And the vertices allow me to give the hyperbola the appropriate shape. So once I have my asymptotes drawn, I'm going to draw two smooth curves, each passing through the vertex, and I identified the vertex at negative 5, 0 and 5, 0. So it's going to pass through the vertex, and each branch is going to approach the asymptotes, but it's never going to touch the asymptotes. And there in the red is the graph of the hyperbola. So we find the center. We use the values of a squared and b squared to identify the vertices and covertices. From there, I draw my rectangle, draw the asymptotes, and then create my curve. So in our last example, we have the equation y plus 2 quantity squared over 4 minus x minus 3 quantity squared over 1 equal to 1. So the first thing I notice is it's a hyperbola because I have y squared and a negative x squared. They're being subtracted. So I recognize it's a hyperbola. The y variable is listed first, so I know I'm going to have a vertical transverse axis. So the branches of my hyperbola are going to open up and down. To find the center, I take the values of h and k. So the value of h is going to be is 3, and the value of k is negative 2. So h is always grouped with the x, and k is always grouped with the y. So that's why we get 3, negative 2 for the center of the hyperbola. Next, I'm going to plot the vertices and covertices. So my vertices lie 2 units up and down. So 2 units above the center and 2 units below the center. And my covertices lie 1 unit to the left of the center and 1 unit to the right of the center. And those values were from taking a squared and b squared. A squared is 4, and the square root of 4 is 2. And b squared is 1, the square root of 1 is 1. So there are the coordinates of my vertices and covertices. Those are the plots, and now I'm ready to draw my rectangle. So I draw a box around the vertices and the covertices, and there's the rectangle that's going to provide me with the proper asymptotes. So now I'm going to draw diagonals of those lines, and that represent the asymptotes. And then finally, I'm in a position to graph the parabola. So I'm going to draw a smooth curve passing through the vertices at 3, 0 and at 3, negative 4. Those are the vertices. And then the curve is going to approach but never quite intersect the asymptotes. And the red curve represents the hyperbola. So that wraps up this lesson on the equation and graph of a hyperbola. Please email us if you have any questions, and good luck on the quiz.